Welcome to this new video on Git. We now moving into how we can merge branches. But before doing this, let's see where we are. First of all, I'm issuing this kind of git config -- global alias logf blah blah blah. So I'm using the log -- graph one line all decorate all the time. I'm giving a nice alias logf so I can use git logf command and I have this nice output. The situation is this: we have a master branch where I have a content. So if I'm issuing a git checkout master, I moved on master branch, and that is the content of the hello-git.ts file on the master branch. Then I created a bug 123 where I modify the file, and it's another branch. So let's remember, each time I'm using the git checkout command for switching branches, I'm actually telling it, hey, switch branch, so change the branch pointed by the head file and change the content of all the files in working folder to match the content that file where I take the snapshot. So if I'm using git checkout bug 777, I have another content of the file. That's the very nice thing about Git. You are working on a folder, and the checkout command can move you between branches, and each time you move between one branch or another branch, the content of the working folder, it's changed to reflect the content of that master. That reinforces the model of Git that is take snapshot of a folder. Each time I issue a commit, Git take the snapshot of all files on the folder, and then it create a commit that stores a tree for all content of the file. Actually, that's the graphical situation. I have my master, so I have one content of the folder, then I fix the bug in a branch, and I fixed another bug in another branch. Now, the situation is this: how can I close those branches on the master branch? Because a master branch is where the real code is stable, where the code it is. Using other branch for fixing bug is useful for fixing bug, creating feature in complete isolation. But when the bug is corrected, the feature is finished, I'm expecting those kind of branches to be remerged in master branch. So these are a temporary branch. They are alive only for the time needed to fix a bug or create a feature, and then all the modification should be merged into master branch. Before moving into physically merge these branches, you need to understand that you're looking at a tree. So you have a tree composed by commit. All commits are like having a zip file with the content of the folder in that branches. Now, let's try to close the bug 123 branch. So what is happening? I have the master branch that is pointing to a commit. I have the bug 123 that is pointing to another commit. And I have a path that directly bring my bug 123 branch into master branch. So this means that the bug 123 branch is derived directly from master branch, and that's an important thing. So let's see how we can merge the bug 123 branch into master. Okay, first of all, you check out master just to move on the master branch, verify that you are indeed on the master branch. Now, I want to close the bug 123 branch. So from the master branch, I can issue the git merge command with the bug 123 branch. Okay, the command means I'm on the master branch, this is my current branch. Merging with another branch means take all the modifications that are in the bug 123 branch and incorporate into my master branch. And I have a nice output, fast forward. Let's see what's happened. Actually, since as you've seen before, the master were pointing to this commit, actually, if I'm telling Git to incorporate the modification of the bug 123, the commit B, D, 5E, blah, 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 onto master branch, Git can only change the content of the master pointing to this new commit. That's because there were a path pointing from the bug123 to master branch. So there's nothing in the master branch that's not in the bug123 commit. So it is a fast forward. Just to understand, let's try to rewind and see how the situation was before. Because one thing that is really nice about Git is you can always move pointer around. So let's suppose you want to undo those merge. I'm in the master branch, so if I miss you git log f again, you can see that were the previous commit pointed by master, but now master is pointing to the BD5E494. Another command that is really important is git reset hard, and even if some people tells you that this is a destructive command, actually it's not so destructive. But actually, just see at what this command does. It takes the content of the actual branch file, so the master, and move to another content. So if I'm issuing this kind of command, git reset --r dadd, okay, and I issue git log f again, I'm back to the very same situation I was before the merge. So git log f is git reset --r is nothing else than taking a commit, change the content of actual branch into that commit, and check out those contents. So actually I can do even with direct manipulating the file inside, but that's not supposed to happen. But as you see, as I show you before, these are branch files. So actually, let's suppose I want to do the merge manually, since I can verify that indeed I have one direct path that brings from my master to bug123. I can take the content of the bug123 folder. I can copy the content inside the master file, and now I can issue a git checkout --dot to make all the content of the folder point to the bring back to the very same content of my branch. And if I issue a git log f, as you can see, I've done the same thing as merging. So I've moved my branch master on my bug123. So that's the simple way of merging when you have a fast forward. Now that you merge your master into bug123, it means that every developing that was done in the bug123 folder, bug123 branch, was incorporated into the master branch. The bug123 has no more reason to exist, so you can git branch delete bug123. And that's all. You had fixed the bug in isolation into a different branch. Then when the fix is finished, you come to the master branch, you issue a git merge command to incorporate all the modification on the master branch, and then you can delete the original branch because it does not need to be around anymore. If you want to bring back, you can simply issue a git branch bug123, and the branches come back to life again. So it's nothing special. You are only working with file. I can directly delete a file into the ref adds, and I can get git log f, and the bug123 branch was gone. Now, really different things happens when you want to now incorporate the content of bug777 into the master branch. So the idea is, okay, I have a really new situation where now there is no direct path that brings from the source, the first commit, to the master, to the bug777 branch incorporating the master, because this commit here is the commit that was done in the bug123. So now if I'm issuing a git merge from master to bug777, Git has to use a different strategy. The idea is Git is not able to take the master file and point to a new commit, because if it will point directly to this commit, the content of this other commit will be lost, okay? So that's a standard situation because you have a graph and the graph does not have any way of reconciling those two differences if not creating another commit and pointing to this other commit. So let me show you the result. At this point, I want to close the bug 777 branch. I finished fixing the bug and I'm on master branch, so I'm issuing the git merge bug 777 branch. Okay, a nice output is done, explaining you that the merge was made by the ORT strategy. Now, even if you don't need to know what is the real ORT strategy is, what happened behind the scene is what I've told you before, okay? Nothing different. So the idea is the branch master was on this commit. The bug 777 was on this other commit. Now we have a problem. If I want to incorporate the content of this commit onto this other commit, the only way I can do this is creating another commit that contains both modification, the modification made in the old bug 123 folder and the modification included in the bug 777. If there are some conflict on the file, you need to fix that conflict, but that's another story. We had no conflict, but even if we had no conflict, I have another commit containing the composite changes of the two branches. Coming back into the command line, I have this new commit, and if I'm going to issue a git cat file -p, I have a nice commit. We have two parents. So that's the real difference between Git and other source control. Since it's not a source control, but it is more a tool for taking snapshot of a folder, you can have different branches. So you can start from a common content, take a snapshot, change a file and take a snapshot, then come back to the original content, change other files, take another snapshot. So now you have two snapshots that are derived from a same snapshot. If you want to reconcile those modifications, the only way you have is to creating a new snapshot that is pointing to both parent commits, and now you can simply issue a git branch.debug 777. You can simply delete the branch 777 because it's not to be used anymore. It serves its purpose. And here is the situation. Thanks to Git, you were able to take one bug fix, then move in isolation and fix another bug in isolation. And when you finished fixing those bugs in different moments, you were able to reconcile them to the single master branch. And that's the main purpose of Git, allowing you to work on isolation with this easy way of creating branch, working on a branch, and closing a branch. For this video, it's everything. In the next video, I'll show you a more smart way of reconciling the branch that keeps your history linear.